Welcome to all. For your information, this is the last question of our part 3, right now last. That is centroid and moment of inertia. Centroid already number of questions we covered more than 100. Moment of inertia 163 today. This only will tell you how much elaborately I am covering the chapter. Then I have decided now, like a grand final or closing part of moment of inertia right now. By chance, due to some reason, either due to some request from those who want to learn, sometimes they put a request, we want to solve this question, or for any other reason, if I feel extra questions are required, in the playlist, I will put separately additional questions for engineering mechanics, part 1, part 2, part 3, that way I will put it. So, in the series now, in the class number point of view, this is the last question. And what I will do is, this question I have decided to explain each and everything as much as possible. See, all the concepts of centroid, moment of inertia, its own axis, parallax theorem, standard expressions, earlier so many times repeated, but still briefly I will explain. This question will cover the entire chapter of centroid moment of inertia and also go through entire class repeatedly till everything is clear. And question you should understand correctly. See, right now, question 163. See, I'll write here. What is required? What is required? Required. I will tell later, or I will give later. I will write or question required. I will tell later. Okay, tell it later. There's a reason for it. Okay, all dimensions in millimeter. See, first this I will remove now. So remember, this is like real, ultimate master question. You can make a note here. See, total 10 parts are there. Nowhere you can see a question given or solved where number of parts are 10. Usually 2, 3, 4 like that. So this I will remove. I should properly adjust the writing so that everything will come clearly. Okay, now, before I tell what I told question 163. What I require, I will tell you later. So, right now what you do is, see, right now what I will do. See, right now what I will do is, I will explain this given sketch. See, all dimensions millimeter. Find what I will write later. Regarding the division part, I will tell correctly. And all the dimensions, how to fix all the dimensions. Okay, start. First, remember. So, whether they want moment of inertia about centroidal axis or some, see, what they want is, they may ask moment of inertia about centroidal axis or some other axis. That all will come later. See, whatever they ask, division is required. So, now, right now I will tell division. See, correct here. Height 1, I will start from here. I will start from here. 1 point I will start. Height 150. From here I am starting. Height 150. Don't see other things. This is 150. Okay, this point came. Then, this baseline required. The base is not given. So what to do? Wait for some times. Or it's given, see here. This point and this point both are, see, these two are in the same vertical line. See here. Therefore, this base will be this diameter plus this 70. Radius 65 means diameter is 130. Be careful. Radius 65 means diameter is 130. 130 plus 70, you will get from here to here. You should write all these or repeatedly go through explanation. Writing is difficult. Or you are write some A, B, C, D, etc. You are write. See, A, B, C, D. Then you decide some name will come, say Q, R. How to get Q, R like that? Or till you get grip, you go through this class again and again. Practice. Then write it. So make a note here. See, like this distance we can calculate by 65 radius, total 130 diameter. So 130 plus 70 is 200. So that's how I got the from here to here base 200. So this triangle height 150, base 200. So number I'll put later. This is your triangle figure number 3 later. See, this is your component number 3 later. Okay. So I fully explained 3. Okay, then this is, see here, light line if you want. See, this is quadrant of a circle, radius 150. So this also 150, this also 150. So 150 here, 150 here. See now, 150 here. And this also 150. You write either here, see, but I wrote it here, see. This height I wrote here because some space required, see, 150. So this 150 height of this triangle is also this height. So this is your component part number 5. So this I explained already. Its diameter is 300. Why? Radius is 150 means diameter 300. So these two are clear. Now 200 clear, 150 clear, and this 150 clear. Then there is a triangle here, see, this way. This is 150, you know it. This is 75. If this is 75, this also 75. Why? 150 minus 75 is 75. So that means this is an isosceles triangle. I told you, if it is isosceles triangle, don't divide into parts. Take a single. So that's why, see, I put this is figure number 6 common here. See, little later, see here, this triangle I made 2 separate triangle. You can see here 1 and 2. But here not that way. See, when I write, if I separate I want, I will put some number here and number here. I put a solid line here. See, that means this complete triangle is a single triangle. You are taking isosceles triangle. This baseline is 150. This 75, 75 each. This height is 100. How 100? Given in the question. See, 100 given. So figure number 6 also clear. Okay, then come down. There is a gap of 50 mm here. From here to here 50. See, that is where from here a semicircle is cut out. See, cut out. Later what I am doing? I am taking one full rectangle here. Then this is cut out. So see, if I take a full here, I took a full rectangle here. So from the rectangle, this is cut out. So the cut out portion, see, red color I made, partial red. See, here this also, fourth is something else actually, come later. So therefore, they told this is 50. You can write wherever you want, but I wrote 50 here, see, for some reason. Because this 50 is also base for this triangle. See here. See, if I divide into parts here, it is the base here, and also given in the question. See, in the question given that these two are same level. So if this is 50, this also 50. So 50 is clear. Then this radius is 60. When radius is 60, diameter is 120. See, where 120? See, from here to here is 120. This is 120. See, I wrote here 120. Therefore, this is given 50. This is 120. From here to here will be 50 plus 120 is 170. Make a note. 170 over. Then come this side. There is a triangle, one more triangle here. See, one more triangle. This also, see, base is once again 150. See, same base. Like, see, this 150 means base 150. 150 base. So again told 75 means this and this both are equal. Means once again this is an isosceles triangle. So don't divide into parts. Take a single triangle. See figure number 9. For that one, base required. See, you can see the base there. See, 150. Height is 90 given in the question. See, height is 90 given in the question. Not 90 given. Now you got this 90. So one thing now only, the topmost to bottommost level. See, the topmost to bottommost level. See, there is one more here, but this level is further down compared to here. This is 75 plus 75, 150, 150 plus 170, 320, 320 plus 90 is total 410. Okay, that is clear. Come this side. There is a gap of 70 here. See, after this triangle is over, there is a gap of 70 here. See. 70. Then there is a semicircle of radius 65. I already explained to you diameter 130. So this using this 130 and 70 only, we got 200. Okay, come here. This is diameter is 130. So when diameter is 130, radius is 65. So this bottom edge and this bottom edge, there's a difference. How much difference here? This is 90. This is 65. When that is 90 and this is 65, it is not 15, it is 25, correct? 90 minus 65. Oh, it is not 15, it is 25. Okay, no problem. I have not used it. It is 25. By mistake, I put what? 20, no problem. Okay, 90. It is how much? This is, see, diameter is 130 means radius is 65. 65 here, 90 here. From 90 subtract 65, you get 25. This from here to this level is 25. If you require it. If you require it, I have not used it. See, I already found the value of x bar, y bar. But that time, I have not used it. Suppose I used 15, I have to revise all the calculation now. Okay. This is also clear. See, this level. Bottom level. Then, this is 65. Why? Radius 65. Okay. 65. Then, anything else? Nothing. Now I want from this right, see, from this right extreme end, always remember extreme end, see, to this left extreme end, this full distance required. Before that, I want to base of the rect, 1 minute, before that one, number of parts to be divided. One more thing I not told here, see, this is, see, I told you, this is 50, this is 120. You already know it, see, total 170. In 170, this is how much? 50. This is 120. So, this is not a right isosceles triangle. Therefore, it is a random triangle. If a random or general triangle is there, you will have difficulty for moment of inertia. So, if they give right angle triangle, see, right angle triangle, happy, proceed further. If isosceles triangle given, again happily maintain as it is, don't divide. But if a random triangle, general triangle given, divide into two right angle triangles. So I divided into two triangles here. This triangle base is 50, this triangle base is 120. Height common for both 110 given in the question. Now, this rectangle, you want the height of rectangle. See, already I told you, it is 170. And base of rectangle required because area purpose. Base of the rectangle is 75 plus 75, 150, 150 plus 70, 220, 220 plus 130, 220 plus 130 is 320, 320 plus 30, 350. Sorry, this RS is not there. It is advanced one. Don't worry about it now. This is not there. Right now it is not there. Okay, I don't know why I wrote it. I actually wrote first, I changed it. I have not told anything about RS PQ all. Time being, I have not told. See, little correction means problem comes. Okay. Now, therefore, this is 350 clear. Now, the total from left extreme end to right extreme end total is 110 plus 350 plus another 100. 350 plus 100 is 450 plus another 110, 450, 550 plus 10 more, 560. I wrote, I think it is visible most probably in the camera. I will check it once again. Most probably visible. Yes, I have to slightly lift the camera. No, not required. Okay. I slightly lift it. Not too much lifting. Slight, I will write once again. And this 560. See, the total is 560. I think now it is clear, 560. Somewhere here, okay. I'll round off that one. 560. I check once again the camera because these are all small things. 560. So that nothing should be not clear. Okay, now okay. Little inclined it became. Don't bother about those simple things. Inclined line, little zigzag line, straight line is not maintained. That is for those people who unnecessarily want to comment. See, there are people who want to comment unnecessary things. They have no intention of learning anything. They are busy only commenting. Let them do it. Okay, I'll make more clearly. 560. Okay, now clear. Okay, now total height is 410. I told you from this bottom level to this bottom level, 25 gap is there. This is dividing into parts. Now, still I will not tell what I want because, next. Now I will tell you what they want in the question you see later. Master question. But I will see, actually I will tell you what. Once they want I about P, Q and RS as an independent question. Next question is finding I about centroidal axis. Next question is special. Everything same question. Special. Find centroidal moment of inertia and using that find about some other axis. Everything today we are closing it. So therefore that's why I wrote only question 163. See what is required I am not told. Now make a note. Whatever is required, you should understand correctly division. So what I will do is, see, this, I will start from here. Any way you can start. See, this I will take part number 1. See here. This I will take part number 2. In order I will go 2. This full, I think forgot. There is a circle cutout here. See, I forgot it. A circle cutout of diameter 45. See, circle diameter is 45. Then it is given that cutout is from the top edge at 50. See, from here to the cutout is 50, and from here to cutout edge is how much given? 15. So this is 15 given. This is 50 given. Important. Okay, now everything is clear now. I will tell you part number. You should write here. Part 1. See, all green color today. Once again back to green color. So part 1 is right angle triangle. That is, see, this triangle. Okay, over. Part 1. Part 2 is another right angle triangle which comes below of base 120, height 110. Part 2. Part 1 over. Part 2 over. Part 3 is once again right here, right angle triangle of base 200 and height 150. Remember, base 200, height 150 is part 3. Okay, 3. Whereas part 4, be careful, it is the cutout portion. Therefore, what I will do is danger 1. See, the negative sign important. I will put red color. Part 4, first I put green. I painted with red to give a warning. See, part 4 is a warning is there. Warning with red color. For part 4, warning color is given. I told you why warning required. Sometimes people in a hurry, they make a mistake. Warning, over. Part 5 is this quadrant of a circle. Diameter 300, told. Part 6 is this entire isosceles triangle is part 6. Full triangle, see, single. Part 7 is our rectangle. See, I won't write here now. Part 7 is rectangle. Part 8 is this cutout semicircle. So part 8, be careful, little red painting. So remember, same way as you come down and down and down, part 8, once again, there is a warning. Warning, it is cutout. Okay. First green color, then paint with red color. Part 9 is this isosceles triangle. See, I wrote here because it is both together. Part 10 is this, which one? Semicircle, that is part 10. So I explained all the parts. Now what I will do is, see, now what I will do is, I will tell you what I will do. I want this question to be memorable question. Anybody who want to study complete chapter, if he studies, if he or she will go through, if he go through this class, reply should, finally, they should admit, yes, this question will make the complete chapter clear, single question. Once this question is clear, if you see the word questions, so many should laugh. So simple, see. So this is really ultimate master, ultimate to ultimate master. Because our grand closing of moment of inertia. Okay, now, what I will do now is, see, I will remove this one now. This sketch I am removing, very important. I am removing. What I will remove and make a note. What he will do now? Still he has not told what is required. What is required will come little later. You have patience and go through the class. You see, when I am uploading the class, I am making adjustment in the recording so that I am removing now. For you it is removed, for me it is still maintained in some other way. That I will backward, forward, I will advance part, I will record first. I won't get confused. I will not confuse you. So right now what I am doing, see this full I am removing. See now, fully removed. Okay, fully removed. Now this is not required now. Okay. Then I will explain all properties of the component once again, so that you get a complete grip on that one. Once I explain all the properties for this one, here, one by one, I will ask you, I will come here. Hey, come here. Which one? Hey, that 6, come here. I will ask you to come here. When it comes here, I will explain that one. You make a note of that one systematically. Before you start the real question, what is required? Patience required. See, what is required to know, patience is required. Okay, now, therefore, I will remove this one now, everything. And then some will tell, sir, you removed it, sir. Again it came. That is my trick of recording, adjustment in the recording. I will, little part, next to what I am coming, I will record now and store it. Sir, confusion. For whom? For your confusion, I am removing. My confusion, don't bother. I am not that person. I am not that type who will get confusion so easily. Not so easily. I will not get confusion. Okay. Now this I will remove. And what I will do, part I will sit, I will here, I will stand. Come. Each one of you come here. I will treat you, I will give a treatment to you. What treatment I will give you, I will tell you later now. So be ready for treatment for each component, or once again revision for, see later when you find centroid, locate centroid, and when you find moment of inertia, what you require, you should know correctly what is area for each component and where is centroid for the component G1, G2, G3, and I about its own centroidal axis. That's required. That all I will explain now. Make it ready for operation, then I will start. You don't bother how I manage it. I am going to manage it now. Okay. This I am fully removing now and I start. Now, as I told little earlier, I will call each and every component and explain the properties of the component. See, these all already over many times, not 10 or 15 times, so many times over. Exclusive class are taken earlier. See there, all thorough explanation for component property, but still it's a closing question. I want to explain briefly so that anybody who has not followed earlier, at least now they should realize, oh, we should have studied everything from earlier. So therefore, start one by one. I will tell what all required properties. Come to first part 1. Okay. Green color. See, now it is a green color. You call part 1. Part 1, come here. Where are you? Here. See, part 1. See, part 1 is a triangle. See here. This is and this way. Dimensions I will write here. This is your part 1. See, the height is 50. Be careful. Don't tell me, sir, you wrote right side, it is on left side. I will tell get out. In the class, if someone tells that way, what? Sir, here 50 is on the left side you wrote, but here you wrote right side. I will tell immediately throw him outside. This is 110. This is part 1. So, okay, see, you can see the name there. See, this one, part 1. Somewhere I wrote here part 1. Its area required. See, its area. That is A1. A means A1. Half into base 110 into 50. This everybody knows. You can write either half into 110 into 50 or half into 50 into 110. Whatever way you want, you can write. Okay, then Where is its centroid? See, come to right angle point. Right angle is here. From there, both sides, see, right angle, first make a note here. This one is right angle triangle, same property for 2 and 3 also later. Once I explain 1, 2 and 3, briefly I will explain. Because why? 1, 2 and 3 all are right angle triangles. So, right angle triangle. Come to the point where 90 degrees there. See, both ways divide into 3 parts. And go to the first part here and first part here. Come here. See, first part here and see this point and this point intersection. This is your G1 centroid. Okay, now therefore this distance is 1 by 3 of 50. If you want this distance, it is 2 by 3 of 50. Same way, this distance is 1 by 3 of 110. This distance is 2 by 3 of 110. Y means you can make out smaller, bigger, smaller, bigger. Okay. Now, G1, look, see, I located G1, see here. See, 1, 2, 3 parts, intersection point I took here. Then, you consider horizontal axis passing to centroid. Also consider a vertical axis passing to centroid. We want I about IG, means I about this axis. We want I about this axis. Later you require. For a right angle triangle, when you want moment of inertia about centroidal axis, what you do is, first you start from side parallel to the axis. See, for this axis, parallel is 110. So, side parallel to the axis into perpendicular side 50 cube divided by 36. I about this axis, see, this axis. For this axis, side parallel to axis. For this axis, parallel is 50. 50 into perpendicular, other one is, once you write 50, other is 110 only. 110 cube divided by 36. This is property of 1. This is told, I think, more than 100 times already. But still, I am telling once again so that it is beneficial for all. Okay, part 1 over, goodbye. Nothing else further. I will call part 2 now. Every member I will call here. Come, one by one, come here. You get a treatment from me and go back. Later, remember, when I want later, I about this axis, I will write 110 into 50 cube by 36. If somebody will ask why means, leave my class. Okay. Come to part number 2. Right here. Part number 2. Right here. Part number 2 also is, and you should, what all I dictate you write, is also right angle triangle. It is like this. See here. It is like this. This is how much? That is 110. But this is bigger. How much? 120. This is 120. See there. 110 is this one, 120 here. Join. Okay. So its area equal to half into 110 into 120 or half into 120 into 110. Come to 90 degree angle. See here. Divide into 3 parts. Divide into 3 parts. From here, first part, here first part. That intersection here. This is your G2. See here, G2. First part, second part, third part. First part, second part, third part. First part, either side, intersection. Okay, now, this distance is, see, this is 1 by 3 of 120. This is 2 by 3 of 120. Same way, this distance if you want. This is 1 by 3 of 110. This is 2 by 3 of 110. Okay, now there is one axis here horizontally passing to G2. I want that IG. Why I want? Later for parallel axis theorem. Also I want I about this axis. These are all green color. See, I about its own centroidal axis. When you want I about this axis, parallel side is, this also is a right angle triangle, parallel side is 110. 110 into other side, perpendicular side is 120 cube by 36. I about this axis is, for this axis, parallel side is 120 into perpendicular side is 110 cube divided by 36. Okay. Say goodbye to 2 also. 2 also clear. See later when I want this Ig or this Ig, directly I will write. I will tell if not clear, better not continue from my class. Figure number 3. Call figure number 3. Hey 3, come here. Somebody will tell, sir, in figure 3, a circle cut out. Cut out later. You see figure 3 is a full triangle. See, comes to component number 3. 3. That is this way and this way, little this side. Space is there. This way, how much it is? 200. This is 200. Height is 150. Don't see other things. See only this much. Don't see this 50, 45, 15, etc. See only triangle. This is your figure number 3. Okay. I forgot last time 2. It is area. Okay. Why waste time area? Area equal to half into 200 into 150 or half into 150 into 200. It's centroid. See, come to 90 degrees. See here. 3 parts. 3 parts. Here. Near, see, centroid is near to these two. Okay, now, if you want this distance, it is 1 by 3 of 200. If you want this distance, it is 2 by 3 of 200. Whereas, in case you want this distance, okay, where I write 150 this side without spoiling. See, 150 it come here, 150. Okay, 150. This is 1 by 3 of 150. This one is 2 by 3 of 150. Okay. Figure number 3. Now, if you want later, see, this is your centroid G3. I think last time I forgot to mark it for this one. I forgot to mark G2. You mark, if I mark G, you mark G3. Okay, now, if you want I about this axis, horizontal axis, and vertical axis here, see, I about this axis, this Ig is, for this axis, parallel is 200. And for this Ig, parallel is 150. So, for this Ig, 200 parallel, 200 into perpendicular is 150 cube divided by 36. This Ig, see, parallel is 150. 150 into how much? 200 cube divided by 36. Okay. 3 also over. Come to fourth one. Okay, I'll remove this one now. Come to fourth one. Later remember, your fourth one is a cutout. Okay, fourth one. It is a circle of diameter. How much diameter? Diameter equal to 45. 45. Its centroid is here. The exact center. This is your G4. Area for circle is pi by 4 of diameter square. Okay. Then centroid is directly at center. Don't write formula. Exact center. So G4. Now this is axis, horizontal axis. This is vertical axis. For a circle, I about any axis passing to centroid is Ig equal to pi into diameter power 4. What is diameter? 45 power 4 divided by 64. This Ig also equal to pi into 45 power 4 divided by 64. For a circle, whether it is horizontal axis or vertical axis, for a circle, centroid at center and I about any axis passing to centroid is pi into diameter power 4 by 64. Okay. Fourth one over. Fifth one. Where is fifth one? Quadrant. Be careful. Fifth one, quadrant. Right here, it is a quadrant. See here. It is like this. We should be very, very careful now. This way quadrant. We want its diameter. Its diameter is how much? 300. And remember, this distance is 150 radius. This also 150 radius. Now, First area. Area equal to circle area is pi d square by 4, semicircle area is pi d square by 8, quadrant area is pi d square by 16. So pi into diameter square, 300 square by 16. 300, okay. Area clear. Where is centroid? Like right angle triangle, see, centroid is near here, but not 1/3, 2/3. Little closer here, little closer, see. This is centroid. G, here it is G5. Now, distance of centroid, see, not from here. They you can see a base type here. From the base perpendicular, see, two perpendiculars are here. You don't write this side, see, here means you require reference here directly. Locate G5 with respect to center. See, this is your center of circle. So, this distance or this distance. See, I write here. Both are 2d by 3 pi. Both are 2d by 3 pi are equal to, both are 2 into diameter. Diameter is 300 divided by 3 pi. Therefore, later when I want this distance, it is 2 into 300 by 3 pi. When I want this distance also, 2 into 300 by 3 pi. And I, there is a, this is horizontal axis passing to centroid, and this is vertical axis passing to centroid. See, we want this IG and this IG. Remember, for a quadrant of a circle, when you want IG, pi will not come, a number will come. That number for a quadrant, whether you want this axis or both axes, is 0.00343. Here also 0.00343 into. So for a quadrant of a circle, whether you want about horizontal axis, horizontal centroidal axis, or vertical centroidal axis, see, there is no symmetry here. No symmetry here. That number both are 0.00343 into diameter power 4 into diameter how much? This all I given earlier. You should copy it. I am giving only for this question. I am not writing formula now, but I am explaining for you. Diameter is where is diameter? 300 into 300 power 4 into 300 power 4. So later, when I want this IG or this IG, I will write both of them 0.00343 into 300 power 4. Okay. With that one, fifth over. Now sixth one. Sixth one is, be careful. Sorry, I will do one thing now. Sixth and ninth, I will take simultaneously. There's a reason. See, I will take sixth one and ninth one. Where is ninth one? Sixth one is here. Okay. Ninth is here. Okay. Ninth one is here. Sixth and ninth, both, see, this one and this one, I will take simultaneously. Right? You should write both are, you write here, both are isosceles triangles. Means, see, here, this is this way vertical base and horizontal height. Scale not required. Here, see, horizontal base and vertical height. Scale is not required. And here, the base for this one is, 1 minute, I have gone out of camera. No, I think I have not gone out of camera. No. The base for that one is how much? That triangle, where is it? There. Total 150. The base is 150. See, 150. And base for this one is once again 150. See, these two are coincident 150s. Don't mix up. This 150 and this 150 need not be equal. They are, but see, heights are different. They are coincidence. Okay, then for this one, this height is 100. For sixth one, 100. For this one, this height is 90. See, do one thing, both need not be equal, but it is a coincidence. Okay, now, see, this is isosceles triangle. Therefore, If I mark here and mark here, this is half of how much? 75, 75. Here also, by chance same, don't by heart same, 75, 75. Okay. Now, area for this one, half into 150 into 100. Area for this one is half into 150 into 90. Or you can write half into 100 into 90 or 150 also. You can interchange, no problem. Okay, now, see, we don't divide into parts. We take a single this one, sixth one, full. This is what? Ninth one, full. Single one. Where is its centroid? See, you should remember, we come to the base. The base should be, you should make a note. This all explained thousands of times. Base should be the edge. Yes, this is the edge, base. Go along the height by 1/3. See, this is more area this side, somewhere here. This is your G6 here. Your base is here. Go along the height. This is your G9. Now, if you want this distance, it is 1/3 of 100. If you want this distance, it is 2/3 of 100. Here, if you want this distance, it is 1/3 of 90. This distance is 2/3 of 90. This is clear. Then, this is along height. Along the base, centroid is exactly midpoint. So, 1/3, 2/3. This way, 75, 75. See here. This way, 1/3, 2/3. This way, 75, 75. Okay, now, draw an horizontal. Now is the most important part. People get confusion here. See, this is last time I will tell you. In future, I want this IG. And I also want this IG. See, this IG. Later, I want this IG. Wait, right, be careful now. The 90 I will remove. I will put it here. 90 I will write here now. Space problem. 90. I want this IG and I also want this IG. Be careful. Right angle triangle, once again write. Right angle triangle, when you want IG, it is parallel side into perpendicular cube by 36. But isosceles triangle, not that way. Isosceles triangle, when you want IG, you should correctly see whether that centroidal axis is parallel to base or it is in between. See here, that axis. Will that axis is parallel to base? See, yes, yes, see. This axis is parallel to base. See, this is right here. This axis is parallel to base. If it is parallel to base, if your axis is parallel to base, then formula is same as triangle, parallel side into perpendicular cube by 36. What is the parallel side here? 150 into perpendicular cube, 100 cube by 36. Here, see, here, this axis is parallel to the base. So, about this axis, parallel side is 150, this is told hundreds of times, into perpendicular is 90 cube by 36. But when you want this IG, see, this is not parallel to base. It cuts the base. If it cuts the base, one more property, this is midway between the either side. See, this is common base for two separate right angle triangles, or this is axis of symmetry. In a triangle, if the axis is axis of symmetry, coming in between, moment of inertia is once again parallel into perpendicular cube by 48. So here this IG is, see, this IG, where I write? I write here, see. This IG is, no, not that IG, that I already over. This IG, see. This IG is, comes in between. For this one, the parallel is 100, see. Parallel is 100 into perpendicular is 150, 150 cube by 48, 48, 48, 48. Here also, see. about this axis, Ig equal to, this is, see, this is parallel to base. Okay, same. Base into height cube by 36, but this is not parallel to base. It comes in between, or it is the axis of symmetry dividing into two equal parts. Special treatment for this axis, Ig is parallel is 90 into, or HB cube. Here see BH cube into 150 cube by 48. Okay. Now, which one over? Sixth over. Oh, sixth over. Okay. Sixth over. Along with the sixth, ninth also over. Now remember, later what I will do is, if I want this distance, I will tell 75. If I want this distance, I will tell 1/3 of 100, 2/3 of 100. Here, if I want these two distances, 75. But if I want this distance, 1/3, this is 2/3 of 90. If I want I about this axis, I will write 150 into 100 cube by 36. But if I want I about that middle, see, symmetry axis or the axis in between, which divides two parts, see, that common. If I want I about this axis, I will write 100 into 150 cube by 48 here. If I want I about this axis, I will tell 150 into 90 cube by 36. Why? See, it is parallel to base. But if I want I about this axis, I will tell it's a symmetry axis. See, comes in between. For that in between axis, I equal to 90 into 150 cube by 48. Okay. Now, 6th over, 9th over, 7th one. Okay. 9th already over now, 7th one. See, this type of treatment you cannot see anywhere. I will guarantee bet. I cannot bet. I don't want to bet gamble. Okay, you show one place where this much explanation, this much patience is shown by a person who is teaching the subject. Show one person. That too, consider my age, second factor. Okay, leave age. I still feel young only. Age is only for my body. Mentally, I still think I am quite young. In the house all they will tell, you think you are very young. Yes, I am very, very young. They tell, you took sometimes 6-7 hour classes. It is not good actually, tiring. I don't know. When I am in the board, I don't feel tiredness. Once the class is over, I feel tiredness. I never talk like what? Like an old man. Have you ever seen? See, now see, no. Tell with the confidence. Okay, now, 7th one. Your 7th is so easy, waste of time explaining. It's a rectangle, see. It's a rectangle. Okay, waste of time explaining. This side is how much? Full. 350. This is 170. 170. Now, its centroid is here. This is your G7. See, G7 centroid. Now, I should not explain this distance and this distance. Both are 350 by 2. 350 by 2, waste of time explaining. This distance and this distance, both are 170 by 2. 170 by 2, and area equal to 350 into 170 or 170 into 350. See, later, if I want this distance, or this distance, 350 by 2. If I want this distance or this distance, 170 by 2. And I, see, if you want I about this axis, for rectangle moment of inertia, remember, parallel into perpendicular cube by 12. So, about this axis, your Ig equal to, for this axis, parallel 350 into perpendicular 170 cube by 12. About this Ig is parallel 170 into perpendicular is what? 170 into 350 cube divided by 12. Okay, over. Now, which one? 7th over. 8th one. Okay, 8th and 10th. Okay. Yeah, 8 and 10, I will explain simultaneously. Because why? Both are semicircles. See now, to make clear, 8 and 10 I will explain simultaneously because both right here, both are semicircle. See, 8 is a semicircle on with a vertical base. See, this way. 10 is this is a 10th one. 8 is where is 8th? 8th. So this is 8. 8 is a semicircle with a vertical base. Okay, how is it here? See, this way. 10 is a semicircle with a horizontal base. Be careful, horizontal base. See, this diameter for 8th one is 120. Diameter for this one is the diameter 130. Okay, then this is your 8. See, 8 and 10. Centroid. See, now what you do is this is center of circle. Therefore, for both of them, area equal to pi, circle is pi by 4, semicircle is pi by 8 of diameter square, pi by 8 of 120 square. This area equal to pi by 8 of 130 square. Okay, now where is centroid? See, this is centroid. This way, exactly midway. See, symmetry is there. This is axis of symmetry. Centroid always lies in axis of symmetry, but this way it is see this side more area, somewhere here. G8. Here, this way center, this way G10. Okay, now see, this is diameter 120. So if you want this way centroid location, diameter 120, both are 120 by 2 and 120 by 2. If you want this way centroid, both are 130 by 2 and 130 by 2. But this way centroid, see, if you want this way distance here, if I want this distance, it is once again like quadrant. See, quadrant or semicircle, centroid formula is same, 2d by 3 pi. See, it is 2d by 3 pi. This also is 2d by 3 pi. So here 2d by 3 pi equal to 2 into diameter 120 divided by 3 pi. Here it is 2 into 130 divided by 3 pi. Okay, then I about axis. See, this is centroidal axis, one of the axis. This is other centroidal axis. Be careful. I want this IG and also this IG. Here, I want this IG, right here, no space. Okay, here, I want this IG and also this IG. Okay, make a note here. For a quadrant of a circle, centroid both distance are 2d by 3 pi, 2d by 3 pi. But for a semicircle, one distance is 2d by 3 pi, other is center. See, this way is one in one direction, center, midpoint. Other direction, 2d by 3 pi. So here, later see, if I want this distance or this distance, I will tell the diameter is 120, 120 by 2, 120 by 2. But if I want this distance, I will tell 2d by 3 pi, 2 into 120 by 3 pi. Okay, here, if I want this distance or this distance, I will tell 130 diameter, 130 by 2, 130 by 2. But if I want this distance, I will tell 2d by 3 pi, 2 into 130 by 3 pi. Now, moment of inertia, be careful. Once again, right, for a quadrant, it is 0.003, pi will not come. For circle, see, circle is pi by 64, diameter power 4. Quadrant, it is 0.00343 into diameter power 4. Of course, it is derived expression. For a semicircle, not that way. It is not 0.00343, double. See, quadrant is half of semicircle. Quadrant 0.00343 means semicircle is its double, 0.00686. And which one? See, if the axis is axis of symmetry, then pi will come. And Diameter power 4 will come, pi by, but one thing, semicircle means it is half of circle. Circle 64 means pi by 128. One of them is, see, for a semicircle, one of the moment of inertia, centroidal moment of inertia is pi into diameter power 4 by 128, but one of them. Other one is 0.00686 diameter power 4. How to decide is, which is if the centroidal axis is symmetry axis, then it is same as circle but half of circle, or pi will come. See, circle is pi d power 4 by 64. So if it is symmetrical axis, decimal will not come. See here now. This is symmetrical axis. So this is pi into diameter power 4 by 128, or pi into diameter how much? Pi into 120 power 4 by 128. But this axis, see, this axis is not symmetrical. Therefore, 0.00686 diameter power 4 or 0.00686 into 120 power 4. Here, see, here horizontally symmetry axis, vertically is not symmetry, but here ulta. See, here vertical, this is symmetry right here. This is symmetry axis here. This is symmetry axis. This is pi d power 4 by 128 or equal to pi into diameter 130 power 4 by 128. But this axis is not symmetrical, so it is 0.00686 t power 4 or 0.00686 into diameter is 130 power 4. Okay, over. So therefore, later for this semicircle, if I want this distance, I will put 2d by 3 pi, this way midpoint. This semicircle, if I want this distance, midpoint, but this way 2d by 3 pi. And when I want moment of inertia, if I want I about this axis, see, symmetry is there. Pi by 120, horizontal axis, pi by 128 into 120 power 4. But if I want I about this axis, oh, decimal will come. Decimal for semicircle is 0.00686 into 120 power 4. Here, if I want I about the, see here you see, horizontal axis symmetry here. If I want I about this axis, I will write pi by 128 into diameter power 4, 130 power 4. But if I want I about this axis, not symmetrical, 0.00686 into diameter power 4. So all explained for you now. Everything is over. All basic part are over. Now I will go for last part of thorough explanation. See, really last part before I go further. I should not tell here. This is told hundreds of times. Remember one most important term, that is, for finding moment of inertia, you require parallel axis theorem. Parallel axis theorem. Last time I will tell. I will use red color now. See. According to parallel axis theorem, the theorem is I about any axis. Red color, see, I always do one thing. When I want I about any axis, which axis required, I use red color. It can be centroidal. I about any axis equal to green color, see, green color. Ig plus area into red color, h square. Told thousands of times earlier. You write. You should write. I am not writing now. This is told so many times earlier. You should write it if you want interested. Moment of inertia of the component considered about an axis passing through its own centroid but parallel to the required axis, or this I will call moment of inertia about its own centroidal axis. What all I told now, see, Ig, but that axis should be parallel to x-axis. If you want I about a horizontal axis, you should write I about horizontal horizontal axis, pass into centroid. If you want I about a vertical axis, you should write IG about vertical axis. A is area considered. H is perpendicular distance from what? Centroid of component considered to the required axis. Roughly I am writing because this is told thousands of times, required axis, or from the centroid of the component. See, there are so many. From centroid of component, which axis you want moment of inertia, draw perpendicular. Now, really last time, when you want I about a horizontal axis, all distances are vertical. When you want I about a vertical axis, all distances are horizontal. Why? Perpendicular. And in case centroid of the component considered lies in the required axis, your H will become 0. So many questions are solved earlier. Okay, this is the last part over. Now what I will do is, now I will give the question. See, so far, and I gave the question. First, what I wrote question number 163. What to find I not told. I told first I will explain the division of parts. I will give treatment for each and every component. I told everything I will explain and make ready, and now start. Now I am going for next. I am giving. Next will be question 163. There are 3 questions are there. First one is A. Little later B, C. Remember, all of them you should take, each of them you take as independent question. I will write there. Treat this as independent question. But remember, for all those questions, what all I told till now, what all I explained till now is common. So your class, what they want in the question will start now. I will start it. Okay. Okay. Now we will start the question. See, just you make a note. Just now, he means you should write. He means me. Just now, he cleared the complete division, and also all dimensions. See, when you divide into parts, everything is cleared with thorough explanation, and also for each and every component, individual properties. Make a note. Individual properties. He cleared. See, I all finished now. What I did just now, I called only one here, only 2 here. Each one I told, come here. Come, wait, one, you come here. So I individually, I considered each and every part. Everything is over. Now we are ready for the question. Question 163A. You take very important, see, if you want to understand the concept correctly, what all I tell, you should listen and practice. You take this as independent question. See, today's class question is 163 only. I can make 164. No, I will tell 163 only title. See, later, if any difficulty is there, I can tell, go through entire 163. 163A, you treat as independent question. Find moment of inertia about PQ and RS. See, in the question, I marked PQ and marked RS. Now, one note you are right. I am checking the camera first actually. Visible? Yes, visible. So, question is, it is an independent question. See, once again I don't see, just now I removed earlier. Now it once again came back. How means my magic. Okay. Question is here. Find moment of inertia about PQ and RS. Make a note here, very important note. This is an independent question. You should see what all told up to now. See, before I started 163A, initial explanation is required for all the parts. See, little later 163B is there and 163C is there. For all that one, what all I told up to now is common. Okay. Now, first one thing, see, independent question about PQRS. Make a note. First, make a note here. What is that? How he got PQ and RS? Randomly, see, so many especially academic question paper or competitive examination. I told you one thing. Structural engineering point of view, most and only requirement is moment of inertia about centroidal axis. Other axis not required. But academic examination point of view, so many times they ask, or some competitive examination, they may give. See, sometime I have seen from the rectangle they will show here, they will ask, find I about this axis. If you know correctly, Ig plus A square over. So, therefore, you make a note here. This is to understand correctly. PQ and RS are two randomly given axes. Which one? PQ is a horizontal axis, see, passing through this junction, see here, from here to here. See, here to here, PQ. RS is here. They can give it wherever. See, they can give at the bottom edge, they can give top edge, they can give out. Earlier question I have taken outside also. Does not matter. Or PQ and RS are two axes about which moment of inertia required as an independent question. I told you, independent question, and also those axes he decided. Who? I decided. If you imagine question paper it came. Okay, make a note. Now, what to do? See, I write here. What to do? What to do? Right here. First, divide the given area, entire area, into multiple number of parts. See, right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And write all the dimensions. Yes. Then, all dimensions over. Then further, mark for each and every component its own centroid. Already explained just now. See, G, G1, G2, G3, G4, G5, G6, G7, G8, G9, G10. Okay, already over. Explained already. And then, over. Then, next what to do? Then, you mark that axis. Which one? PQ and RS. Mark here. See, and make a note here. The question is to find I about PQ and RS. And may also make a note here. Here, they do not want I about centroidal axis. They do not want it. That is, they do not want IXX, IYY. See, these are not required. So, no need of locating G. Locating G for the entire lamina using X bar and Y bar calculation. So, right here, no X bar, Y bar calculation, no locating CG, no calculation of IXX, IYY, find only, you just what? Just find I about PQ and I about RS using parallel axis theorem. Using parallel axis theorem. Yes, how? I will tell it now. Okay, over. Therefore, mark it here. See, PQ from here. See here. This is your PQ. It goes here. It goes here. It comes here. See, it comes slightly above G7. Light line mark here. Mark here PQ without disturbing anything. PQ you mark and RS also mark. Mark that RS also. Light line without disturbing anything. Okay, come down. Please come down. Okay, RS. See, RS. Neatly mark it without 350. Come this side. See, 350, you are disturbing me. Come this side. I will tell you 350 to come this side. Okay. Please come this side. Okay. See. Without disturbing mark P, see here, PQ and RS. Okay. Now start finding IPQ. First find IPQ, I about this axis, and after you finish PQ, then find I about RS. Okay, therefore, now what I will do is, I will rub this sketch now. See, this I am rubbing now. Removed. I am not removing. I will record it. See, removed. Everything is over. Okay, therefore, I will rub everything now. See, I am telling I am rubbing everything, but okay, full rubbed out. Okay, full board is empty. Okay, now I will start finding IPQ and IRS and get the answer. Okay, wait 1 minute. Okay, now calculation of IPQ. I will tell one thing. First write, by parallax theorem, I about any axis equal to Ig plus A square. Next time I am not writing. I will tell this, I will call usual statement, that is parallax theorem. If you cannot write, leave. Don't continue my class. Okay, start. See, I wrote what is easy for you. Tough portion I kept pending. There's a reason for it. Because I want to write the important portion in front of you only. Okay, start. First, one by one, fast you have to write. See, first component 1. See, correctly see here. About, I am not marking anything. Its own centroidal axis here. Light pencil, you can mark this way. I am not writing it here. See, next time you can do one thing. Okay, start. Right angle triangle. 110 into 50 cube by 36. Already explained. Plus area into from centroid to PQ, this distance square. Oh, that distance square is exactly equal to, see, this right angle triangle, 1/3 of 50 into 1/3 of 50 whole square. Why? Distance from the centroid of the part considered to required axis. Okay, start. Second one. See, its centroid is here. I about, see, light line you write. I am not writing because I want, it will spoil the sketch. I want to use this sketch more times now. You write here. See, I about its own centroidal axis. Parallel is 110. 110 into 120 cube by 36 plus area into, see, this distance square. This distance square is 1/3 of how much? 120 square. By chance, if they want I about, suppose your PQ is here, then you write 2/3 h square. Here what? 1/3 of 50 plus another 120. If they want somewhere here, it is 65 plus etc. That all already over. Okay, now part 3. That is the right angle triangle. I about its own centroidal axis. Parallel is 200. 200 into 150 cube by 36 plus area into from centroid G3 to PQ. See, this distance square. I want to mark it. This distance square is, this is 1/3 of 150. 1/3 of 150 plus from here to here 150 plus this distance is extra 50 plus 50 whole square. Why? From here to here 1/3 of 150 plus first to come from centroid, come to edge, then this distance. Okay. Fourth one, I about its own centroidal axis. Pi d power 4 by 64 plus area into from centroid to this. See, this distance square is 150. See, from here to here we want, here to here. So see, 50 plus 1, from here we want, start. 50 plus 150, 50 plus 150 will give you from here to the topmost level. Subtract 50, one more 50. This 50 is this 50, that 50 is that 50. Again minus, come to midpoint, 50 minus 45 by 2 whole square. Everywhere you have to calculate the answer equal to. Okay. Then Fifth one, I about its own centroidal axis. 0.00343 into diameter power 4 plus area into, see, this distance square. That is, from here to here is how much? 2d by 3 pi. 2 into diameter. Diameter is how much? 300. 300 divided by 3 pi. That is this distance plus this extra distance is 50 plus 50 whole square. See here, space problem, little small I am writing. You zoom. Suppose confusion means you zoom, and I am dictating also. And one more thing, see in the laptop. Sixth one, I about its own axis. I already told you this all. Parallel is 100. 100 into 150 cube by 48. Why 48? It is told more than 480 times. Plus area into, from centroid to here, this distance square is 75 plus another 50. 75 plus 50 whole square. Then seventh one, rectangle. First I about its own centroidal axis. 350 into 170 cube by 12 plus area into, see, this distance square. That distance square is here. From here to centroid is 170 by 2. It is 170 by 2 will give you from here to centroid. But this is 50. See, we want this distance square. So this half the height, 170 by 2, subtract 50. This is single high school mathematics, whole square. Eighth one, I about its own centroidal axis. Pi into diameter power 4 by 128 plus area into, see, from centroid of the surface here, this distance square is here. Which one? No, so directly see, this distance is directly equal to, see, oh, correctly, where is the distance? See, from here to here, this distance you want. This exactly midpoint, this edge of this one. This diameter is 120. So if it is 120, from here to here is 120 by 2 into 120 by 2 whole square. By 2 whole square. Then ninth one, where is ninth one? Here. I about its own axis. 150 into 90 cube by 36 plus area into, from centroid to this one, this distance square. See here, that distance square is 1/3 of 90 1/3 of 90 plus another, plus this distance is 120. 120 whole square. See, for rectangle you can do one more thing. Instead of struggling, you can do one thing here. See, this is 120. This is 170 by 2. You can also write 120 minus 170 by 2 also. Ninth one over. 10th one. First I about its own centroidal axis. 0.00686 diameter power 4 plus area into, from centroid to PQ, this distance square is 2d by 3 pi. Now I cannot explain, sorry. If someone will tell, sir, not clear, sir, explain once again, means I will tell, leave the class. 2d by 3 pi plus another, from here to, see, we want from here to here is 2d by 3 pi plus this distance square is 120 square. 120 whole square. Each answer you get it. Actually this question, I want the answer. I will calculate. I will do one thing now. When I calculate, this is not there. All the answer I will write in terms of, see, first answer I will tell you. First, I will use 4 decimal. I don't have a calculator here. 10 to the power 6 I will maintain common. So I will calculate all the answers and maybe I may write here. Okay, I will write here. Okay, I have to calculate because there's a reason. Last question, I want to ensure that perfectly tallying answer. There should be not a single mistake in the last question. Now, I calculated all the values. See, first one, see, if it is not clear, slowly I will tell. If because space problem is there here, I cannot rub the sketch there. It took nearly more than 1 hour to write that sketch. I require for next part, see, 1.1458, 10 to the power 6, 15.84, 168.75, 26.0557, 256.0814, 124.2188, 216.1833, 25.4469, 154.9125, 146.5172. Once everything is over, lastly you have to have one thing forgotten. See, when I explained this number, which one? I for sixth one, I told what? 100 into 150 cube by 48. See, I told about this axis. How much? 100 into 150 cube by 48. I told 48, 48, 48, 48 like that. Then when I put the area, I wrote half into 100 into 48 here. Of course, when I calculate, I can make out. Suddenly I realized the mistake. Why? So it is half into 100 to 150. Because of telling 48, 48, 48, in the mind came that height is 48. So I wrote earlier 40. That much common sense is there. Area equal to half into 100 into 150. How 48 will come there? That much common sense is required. But when I calculated, I never saw here. I saw that sketch. See, I don't require writing and doing it. I can, what I will do, I will take my calculator here. I believe in my own capacity. I will do here. See? Okay, this much answer. Okay, therefore, I never bothered. When I took area, suddenly I saw here, and then what I did is, I cross-checked once. When I cross-checked here, this answer was not tallying. Which one? Sixth one. It was giving wrong answer. I thought, what is wrong? Oh, then I realized here, see. I put wrong 148, 150, I put 48 there. Correct it. Now the last step, be careful, and warning for you also. See, last step, this you should do it. I have no time to explain for that one. 1 minute now, camera is okay. Last bottommost line now. Okay, done. After finding all the values, you write. Therefore, see, you should write. I am, therefore, moment of inertia of the entire given area, considering the two cutouts. See, fourth one cutout and eighth one cutout. Considering the two cutouts, I about PQ, final answer. See, therefore, considering everything, final IPQ equal to, you should write. I am not writing. Equal to right there. Once in a lifetime. See, be careful. Fourth is danger. I'll do once again. See, fourth is danger. Fourth is danger. Eighth is danger. Cutouts. Correct? Huh? Yes. Fourth and eighth cutout. Okay. Equal to, you should write here. See, right. IPQ for 1 plus IPQ for 2. See, answers are there. Plus IPQ for 3 minus IPQ for 4 plus IPQ for 5 plus IPQ for 6 plus IPQ for 7 minus IPQ for 8 minus plus IPQ for 9 plus IPQ for 10. Write all the values, find it. I got the answer here, 1032 1032.1464 10 to the power 6 millimeter power 4 is the final answer. See, later when I go to question number 163C, once again IPQ will come, not this way, by direct transfer. I will tell you at that time. At that time I will tell, remember, long back we got the answer 1032.1464. Today we are getting 1032.1463 or 65 because of approximation. Oh, that is exactly same answer we got by another approach also. At that time, remember, this answer required. Earlier some question I told write, double write also. No, this question I want perfect. So remember this answer. Now I will go for I about RS. See, I about RS. Now, first, by parallax theorem, write the statement. I have got space problem here. I do not want this one. Okay, start. I do not want to waste that space. I will use that one. See, first what? Usual parallax theorem you should write. Okay, now I will start writing one by one and finally get the answer. Okay. Okay, now we will continue. Next, last time, see, just now we finished I about PQ, any random axis. Now, moment of inertia or calculation of I about RS. You can write if you want, moment of inertia about RS. Remember, since it's a last question, it's a vertical axis. So for every component, when you write IG, you should write I about vertical centroidal axis. Why? Parallel to RS. And all distances will be horizontal. When you put IG, I equal to IG plus A square, all the perpendicular distance from centroid of each component to RS. See, axis is vertical, horizontal distance. Thousands of times told. Start. IG and area, I will not explain. Why? Before I started only, I told all 10 parts what is IG. Once first, for each and every component, I told you how much is I about horizontal centroidal axis, vertical centroidal axis. Go through it. 10 rounds I have taken it. And maybe hundreds of times I told earlier. Start. 1. See. About its own axis, I am not. If I mark something here, it will spoil the figure because I want to use the figure more times. So you can take a pencil and mark. See, I will remove other things. Previous I will remove. Okay. I about its own centroidal axis. 50 into 110 cube divided by 36 plus area. Area I won't explain. Area into from centroid of the component to RS. This distance square is 200 plus 1/3 of 110. See, I wrote earlier because to save the time. Otherwise, I would write here, go there. So you don't see this one. You see what I am telling. Okay. Calculate. See, first time after a long time, I am writing all the answer. 155.8792 10 to the power 6 millimeter power 4. 10 to the power 6 will keep outside. Okay. Second one. I about RS for second one. See. About its own centroidal axis. Parallel side. 120 into 110 cube by 36 plus area into from centroid here to RS, this distance square. Once again same as last time because both the centroids are 1/3, 1/3. So 200 plus 1/3 of 110 whole square. 374.11. 3. First I about its own centroidal axis. Parallel side 150 into 200 cube divided by 36 plus area into from centroid to RS this distance square. See, directly your RS is edge of the triangle. So directly this distance square, no plus minus, 2/3 of 200 whole square. 300 10 to the power 6. I about RS for fourth one. Be careful. Fourth one is danger. Remember, it is a danger one. Eighth also is a danger. Because danger means it is cut out. Okay, start. First, I about its own centroidal axis. Circle. I told thousands of times. Pi d power 4 by 64. I wrote here. Plus area into from centroid G4 to RS. This distance square is 200 minus 15 minus half of 45 whole square. You get the answer. Fifth one. Here. I about its own centroidal axis. Quadrant of a circle. So 0.00343 into diameter 300 power 4 plus area pi by 16 of 300 square into this distance square. That is 150 minus 2d by 3 pi. Diameter is 300. Okay. Sixth one, I about its own centroidal axis. Parallel side is how much? 150. Here, you can see here, 150. 150 into 100 cube divided by 36 plus area into from centroid to YY. This distance square is 150 plus 1 by 3 of 100. See, I am writing earlier to save the time, and otherwise I have to come here again write one by one, and it will take some time to time waste for calculation. Again I have to calculate. Sometime there will be my calculator has got a problem. I get doubt. So before if I calculate and write it, advantage is that time is saved. Okay, over. Here, next rectangle, seventh one. I about its own centroidal axis. 170 into 350 cube divided by 12 plus area into, see, this distance square. Centroid, see, it's a centroid. Centroid here, this distance square is very simple. 200 minus half of 170. Where is 170 here? Somewhere I wrote 170. Half of 350, not 170. See, this distance square is 200 minus half of 350. Okay, whole square. Answer is there. Eighth one. I about its own centroidal axis parallel to YY is semicircle, and remember this is not symmetry axis, so 0.00686 into diameter is 120, 120 power 4 plus pi by 8 120 square is the area into this distance square. 150 minus 2d by 3 pi whole square. See, 2 into diameter by 3 pi whole square. 89.1239. Ninth one. I about its own centroidal axis. See, this is an isosceles triangle. This axis comes in between symmetry axis. So here parallel is 90 into 150. You can see here 150 cube divided by 48. I told this 480 times plus area into, see, this distance square directly 75 square. Last one. I about its own centroidal axis. This is symmetry axis. So 5 by 128 of diameter 130 power 4 plus area into from centroid to here. This distance square is 70 from here up to here. See, this is 70 plus this is a midpoint. So 70 plus 130 by 2 whole square, 127.9622 10 to the power 6. See, to do all this one, you require infinite patience. For me also. Usually I have no patience to calculate all this. But this is a ultimate question or closing part. I want complete coverage. So, okay. Now, last step. This you should write. Therefore, moment of inertia of the entire given area, considering the two cutout portion, about RS equal to, you should write I about RS for 1, danger is here, plus I about RS for 2, plus I about RS for 3, minus I about RS for 4, the danger, plus I about RS for 5, plus I about RS for 6, plus I about RS for 7, minus I about RS for 8. Why minus means, see, two danger one are there. Lastly, plus I about RS for 9, plus I about RS for 10. Correctly calculate, answer will come 1931.2696 10 to the power 6 millimeter power 4 is I about RS. Okay, over. Now, later I will tell, not now. Make a note. When I go to question, I forgot the question number, 163 I think, okay, whatever it is. When I go to 163, most probably 163, see this, we are in 163A. That is, find moment of inertia about PQ and RS, two randomly given axes. 176B is find moment of inertia about centroidal axis. Most important. There you require X bar, Y bar. I will show the calculation. And 163, I think, most probably 163. C, this question is find moment of inertia about centroidal axis and using that one, find moment of inertia about RS, PQ and RS. At that time, I will tell you, see earlier, when I did I for PQ, we got, I noted the answer somewhere here. Where is the answer? I will tell you later. So where I wrote it? Somewhere I wrote the answer. Somewhere here. Yes. I will tell you at that time. See, long back in question number 163A, I will tell you, we got I about PQ equal to, how much it is? 1032. See, we got just now, earlier. 1032. This is already over now. 32.1464. 1464 10 to the power 6, and I will tell I about RS we got 1931.2696 10 to the power 6. Remember it. Okay, over. With this one, your question number most probably 160. I am getting confused now. Most probably 163. I will check it. Most probably 163. Our last question, part A is completely over. You make a note, in part A, moment of inertia is required about two randomly given axes. It is not centroidal axis. The person who set the question, he wants about PQ and he wants about RS. He can ask about any axis. He wants these two. So that's why we have done it. Person who set the question is me only. Okay, I will tell. Someone set the question. Okay. Now, goodbye to part A. I will change over to part B now. Okay, see, just now we finished that finding IPQ and IRS. Okay, now next question number 163B. See question. Again do one thing, make an independent question as if this is the given question. See, given lamina, once again is there. Some will tell it is same sketch, sir, you can make out. Yes, recording technique. Okay, I adjusted. I thought first what to do. Then I decided backward, forward recording. Okay, but editing after place record, when I join, I properly join it. Okay, see, question is find moment of inertia about centroidal axis. You write that is IXX and IYY. This is the most important part. Most important in structural engineering. Okay. So IXX, IY means XXY. See here, you should write XX and YY passing through G, capital G, centroid for the entire lamina. Therefore, for this question, first we have to locate centroid G. You write here centroid for the entire lamina using X bar and Y bar calculation. As usual, either Abelco or Eterco. I will do both of them. So, using X bar, Y bar. See, right, once you get X bar and Y bar, then correctly mark the centroidal axis here. XX and YY mark here. And then using parallel axis theorem, find I about XX and I about YY. Happily find and get the answer. Okay, now, before that one, first make a note. Whatever is there, first is the division. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which are remote part warning. Warning for 4th one, warning for 8th one. What is warning? Those who are my real students, those who really go through my class, they know it. Warning. And then all dimensions. That all I told in the beginning of the class only. Before I started 163A, that is I about that PQ and RC. Now PQRS gone. See where is PQRS? It is gone. Before I started IPQ and IRS, I told operation. First treatment for each component. That I told, that is component, that is common. Once if common part means common for the entire question. Okay, now, right, x by 1. So therefore, right here, now we will find x bar how much and y bar how much. What is x bar? What is y bar? Go back to centroid chapter earlier. 4, 5, 10 times I wrote distance of horizontal distance of centroid from reference axis, etc. I won't explain. So now you require Abelco or Aterco. Once I will take Abelco, see, to locate centroid, see here, to locate centroid G, once I will solve with Abelco, first I will go for Abelco, and later I will go for Aterco. Both I will do. With the Abelco, I will find x bar, y bar. Actually sufficient. See, once you get x bar from here, y bar from this way here, other you can get it by subtracting. But still, last question, special treatment. After Abelco, I will go for Aterco. The needle, crystal, micro-millimeter accuracy, it will tally. I noted down the answer with full calculator number, like 201.89468144 that way. But when you enter here, we'll use third decimal. But so that I will verify it. So I will go Abelco and Aterco. Abelco, what is Aterco? If not clear, you are not my students. You don't deserve to study from me. After all this one, if someone will ask, see, you have got some responsibility. My class, you should understand, if you study everything from beginning, not randomly come today and study something, that is your problem. If that much patience is not there, dedication is not there, I will tell, don't continue my class. You will learn from a better person. Okay. So now I will go for Abelco. So this I will remove now. See, I will remove this one now. And I already told you, you need x bar, y bar, then moment of inertia. So this full I will remove now. Okay, fully removed. Okay, now I will continue now this one. What? X bar, y bar calculation, locating x, x, y, y there, then finding I, x, x, I, y, y, and get the answer. I will continue. Wait a minute. Resume. Okay. Now we will locate centroid. Okay. Locate centroid now. See, I already mentioned earlier, or in the title also I will put a question which will cover the complete chapter of complete part 3, that is centroid, moment of inertia. We have done more than 250 questions, not 250, 163 here, centroid around 130, 140, nearly 300 questions. One master question which covers everything. So if you understand this question thoroughly, entire chapter will be clear. But one condition is there. Only for those who know correctly what way I teach. See here, I wrote one numbers. Somebody will ask, sir, what is this one? Leave my class. Don't come to my class. I will tell. If by this time, if you do not know the meaning of all these, Abelco, if you do not know what is Abelco, you are not studying from my class. Such people, why should I bother? I am least bothered about them. Show interest, show dedication, study everything, and finally you close your chapter or final touch you give by this question. That's the reason why I told. Okay, now one E5 I have to mark here. I rubbed it for some reason. Okay, don't worry. G5, okay. Okay, start now. To locate centroid G, you write here if you want. See, this all told thousands of times earlier. Centroid for the entire given area or lamina. You require x bar and y bar. We will go for Abelco. See, Abelco here. O. X, Y. If this is not clear, Right now, leave my class. Don't continue. Okay. See, that is minimum requirement. Somebody should not come suddenly to this class and tell, he is not explaining anything. What is the class number? What is the question number? Okay, then, see, part 1, 2, 3, 4th is danger, 5, 6, 7, 8th danger, 9, 10. Area, X, right side, from where? From OY, see, you should write here, X to right side from OY, Y to upward from OX. This is all your responsibility to write. Start. A1, A2, A3, A4, A5, A6, A7, A8, A9, A10. If you do not know how to calculate, you are wasting your time for studying. Okay, leave it now. Start. X. I will do one thing now. I will cross-check the answers. Okay. If anything is wrong, I will correct it because I already got X bar, Y bar, but I want to check it. Okay, start. X1. See, here I wrote direct answer. You should not do this way. You should put a big tabular column where you require length here, some length. You should write this way, tabular column. 1, X. Here you require space for calculation. See the question earlier. See the starting question. I wrote answer here. So you should show the calculation. So lengthwise use the full page. Start. X. See. This way, this way, this way. 1, see, this from, 1 is here. This distance, 2 by 3 of 110. 110 divided by 3. Fifth, what is this one? 110 into 2 by 3. Okay. 73.333. X2, again 2 by 3 of 110. 73.333. X3, centroid of triangle, 100, you should write here, 110 plus 1/3 of 200. 110 plus 200 by 3. 176.667. Okay. This is clear now. Third one clear. Fourth one. Fourth one. 110 plus 15 gap plus half of 45. You should write there 110 plus 15 plus half of 45. 110 plus 15 plus 45 by 2. That is 147.5. Yes, see, I wrote an answer here. Fifth one, see, 110 plus 200 plus 150 or 110 plus 350 minus this distance, 2 times diameter divided by 3 pi. So this total length 110 plus 350 minus 2 into 300 divided by 3 pi. So 460 minus 2 into 300 divided by 3 divided by pi. 396.338. Answer is here. Sixth one. 110 plus 200 plus 150 plus 1 by 3 of 100. 110 plus 350 plus 1 by 3 of 100 is 493.333 or right here. Total 560, see, total 560 minus 2 by 3 of 100. That also will do. That is the best one. See, when you go too much that side, you start from that side. Okay. Seventh one, so simple. 110 plus 350 by 2. 285. Okay, that also clear. Eighth one. See, actually, this is better. What? 560 minus 100 minus 2d by 3 pi. See, 560 from here extreme end minus 100 minus 2 into diameter 120 divided by 3 divided by pi. 434.535. See here. Ninth one, center here. 350 minus 75. Why midpoint? 350, sorry. 110, you should not forget from here you are doing. 110 plus 350 minus 75. 385. See, I wrote here. 10th one. 110 plus this way midpoint. Half of 130. 10 plus 130 by 2. 175. Okay. With this is now y distances. See here. From this way y. Y1. See here. See correctly. Don't see 65. From here to here is 90. 90 plus 120 plus 1/3 of 50. 90 plus 120 plus 1/3 of 50. 226.667. 2. 90. This don't, or if you want to use this one, 25 plus 65. 90 plus 2/3 of 120 plus 2 by 3 of 120. 170. Okay, that also cleared. 3. Here, see. Now 3 is this one. Better go this way. See. 410 minus this triangle. 2 by 3 of 150. 410 minus 2 by 3 of 150 is 310. See here. 310. Or 90 plus 120 plus 50 plus 1/3 of 150. Fifth one. See. 90 plus 170 plus 2d by 3 pi. Don't come from that side because why this is not known. See. 90 plus 170 plus 2d by 3 pi. 2 into 300 by 3 pi. 90 plus 170 plus 2 into 300 divided by 3 divided by shift pi. 323.662. 323.662. Sixth one. 90 plus 170. 90 plus 170 plus 75 by midpoint. 335. See. Or 410 minus 75. Seventh one. Rectangle. 90 plus half of 170. T plus 170 divided by 2. 175. See here. Eighth one. 90 plus this distance. The diameter is 120. See here. 120 is the diameter. So 90 plus half of 120. Plus 120 by 2. 150 is here. Ninth one. 2 by 3 of 90. 60. Last one. 90 minus 2d by 3 pi. So 90 minus 2 into diameter is 130 divided by 3 divided by shift pi is 62.413. With these values, total area equal to A1 plus A2 plus A3 minus A4 plus A5 plus A6 plus A7 minus A8 plus A9 plus A10 will give total area. X bar equal to A1 x1, A2 x2, A3 x3 minus A4 x4, danger, plus A5 x5, put finger here, plus A6 x6 plus A7 x7 minus A8 x8 plus A9 x9, A10 x10, you get X bar 278.4351802. I wrote the full number for some reason. I will tell you later. Actually, you write third decimal, 278.435 is sufficient. That extra numbers are not required. This is for some reason to show that so much perfection is maintained here. Same way, y bar, calculate. A1 y1, A2 y2, A3 y3, minus A4 y4, lastly, minus A8 y8, 212.5176889. Okay, now, some important note. See here. Class, I will tell you here now. Class, what I tell you should write, class. Yes, we got X bar, Y bar with Abelco. Using that one, locate the axis. Okay, locate, you are using X bar, locate YY, using Y bar, locate XX. We will do little later. Okay, little later. Okay, now, do one thing. Or, right here. Or, once again right here. Go for Aterco. Just to understand, make perfect. Again you require X bar, Y bar. Last time your X bar was right, see, was right side, Y bar was up last time. Now your x bar is to left side and y bar is to down with Aterco. So remove this x and y from here. If you are serious, write one more sketch and mark the origin here, O, and then mark here x this way and y this way. And this way get x values, this way get y values, and then get x bar and y bar. Whatever you do, see, when you go for Aterco, your x bar, this is x bar to what side? I told already, that side, x bar and y bar for Aterco has to come. How much? I will tell you how much it has to come. See, from left side we got 278, total is 560. 560 minus 278.435, 1802. X bar has to come 281.5648, not even 197, 198 only will come, and y bar has to come. See, from bottom you got 212, from top you will get 400, you will get it now, 410 minus 212.5176689, that is 197.4823311. 197.4823311 is the answer. It has to come, but anyway, we will check it now. 1 minute. This is remember, this is advance answer written, anticipation answer. Okay, now start. Once again start. In the diagram, you remove this O, put the O that side. Okay, now areas will remain same. Your x and y will change. Again, I will do one thing now. Instead of wasting time, what I will do? I will pause the recording and enter, then continue to save the time. Okay, that much time I will pause the recording because I do not want to waste time. Okay. 1 minute, I will pause it. Okay, now do not see this answer. This is your, see, this is the answer with what? Previous answer. This is your Abelco answer. Don't see it now. Go to Aterco now, fresh. See, if you are doing this one, both are not required, just to understand. Okay, start. X distances, I will check everything. X1, see, I will dictate for you from here. Total 560 minus 2/3 of 110. If by this time, if this is not clear, not fit for education from me, 560 minus 2/3 of 110. 486.667. X2 also same answer. 560 minus 2/3 of 110. X3 100 plus 150 plus 2/3 of 200. 100 plus how much? 150 plus 2/3 of 200. 383.333. Or you can do one thing. See, 560 minus 110 minus 1/3 of 200. Both are same answer. You should write all those things. Fourth one, see, 100 plus 150 plus 200 or 100 plus 350 minus 15 minus half of 45. 100 plus 350 minus 15 minus 22.5. That is 322.5. Where is it? 322.5. Fourth one. How 412.5? 100 plus 150 plus 200 minus 15 minus 45 by 2. Oh, yes, correct. 412.5. Correct. See, One zero has not come properly in the calculator. Okay. Fifth one. 100 plus 2d by 3 pi. 100 plus 2 into 300 divided by 3 divided by shift pi. 163.662. 163.662. Sixth one, directly 2/3 of 100. 66.667. Seventh one, 100 plus half of 350. 100 plus 350 divided by 2 is 275. See, 275. Eighth one, 100 plus 2d by 3 pi. 100 plus 2 into diameter is 120 divided by 3 divided by shift pi. 125.465. Yes. Ninth one, 100 plus 75. 175. Why check the calculator? Last one, 100 plus 350. See, 100 plus 350 minus half of 130. 385, or 100 plus 70, 150 plus 70 plus half of 130. That also will do. Okay, get all the values. Y from top. Start, first one. From topmost edge, 150 plus 2/3 of 50. 150 plus 2 by 3 of 50. All this you have right here. See, a big tabular column. First show the calculation, then put the answer. Don't copy the numbers. It is 183.333. Y2, 150 plus 50 plus 1/3 of 120. 50 plus 50 plus 1 by 3 of 120 is 240. Yes. 3, directly 2/3 of 150, 100. Fourth one, 50 plus half of 45, 72.5. Fifth one, from here to here is 150 minus 2d by 3 pi. 150 minus 2 into 300 divided by 3 divided by pi. 86.338. Yes. Sixth one, directly 75. See, midpoint. Seventh one, 150 plus half of 170. 235. Yes. Eighth one, 150 plus this gap. That gap is 50. You can see these are same level. 50. If you want, write 50 here. If you are that much eager, write that 50 also here. What you are losing? Actually not required. 50 plus half of 120. 150 plus 50 plus 120 by 2 is 260. Yes, see, 260 here. Eighth over. Ninth one. See, directly can do. So 150 plus 170 plus 1/3 of 90. 150 plus 170 plus 90 by 3 is 197. Something wrong. 150 plus 170 plus 90 by 3. 350. Yes. Or you can do 410 minus 2/3 of 90. Both are same. Last one. See. 150 plus 170 or 150 plus 50 plus 120. 150 plus 50 plus 120 plus 2 into diameter. 130 divided by 3 divided by shift pi. 347.587. Okay. You got all the distances. Correctly do with this calculation. Area A1 x1, A2 x2, A3 x3 minus for fourth and eighth one, 1000 sometime told. I can't calculate. I will find x bar, y bar now in front of you. X bar 281.5648198. Oh, yes, see here. Before we started, we told if from left side x bar comes this much, from right side x bar has to come this much. Answer came. See, perfectly same answer. And y bar I will calculate. Some will tell cheating. No, this is called confidence. Y bar. I will read from calculator. Actually, someone will tell, sir, your calculator inverted. Sir, your calculator is showing syntax error. Okay. 197.4823311. Oh, yes. See. Therefore, perfectly tallying. Now do one thing. Remove all this one and use any one of them, either Abelco or Eterco. Okay, I will go back once again to Abelco. See, with Abelco, actually Eterco is only for checking purpose. See, this way X, this way Y. Go for Abelco. Previous answer. Mark X bar and Y bar. X bar, see here, 278.435. 100 up to here, 110. 110 plus 200 is, see, this is also equally important now. Now 110 plus 200 is 310. Oh, before that one, only 278. So, but 110 plus this is 130. 110 plus 130 is 240. Oh, more than 240. See, from here to here is 240. More than 240. From here to here is 310, less than, and also G7, how much here? 110 plus 350 by 2 is 285. We got 278. So, little before G7, but after this point, see here, how much it is? 278, very near. It is very near to G7. See. These are all high school level mathematics. See. This is your YY axis and the space is there. Project that YY without disturbing other and mark here. This is your X bar. See, means up to here, red color. Don't see other things. This is your X bar, 278.435 is sufficient. 435. Then from that side to here will be total 560 minus 278.435 is 281.565. 281.565. Yes, correct. See, that is what X bar we got with Eterco. See there, with the Eterco we got same X bar. Okay. Y bar, Abelco, 212.518 because 5176, I will round off to third decimal, 518. 212, 90, furthermore, 90 plus 120. 90 plus 120 is 210. Oh, little above. And see, up to centroid of rectangle is how much? 90 plus 170 by 2 is 175. It is, see, these two are same level. So this level is how much here? 90 plus 120 is 210. Little above 210. So slightly above. See? Without disturbing anything, mark your X-axis. Little down, okay, see? Little above. X-axis. Space problem is there, means you write X here. And then outside, see? X marking is here. This is 50, something else, this 50. See, this 50 is this 50. This is red color. Okay, do one thing. You write XX here. Okay. XX here. Sorry, XX. From the bottommost edge to XX axis. This distance is Y bar 212.518. Then from the topmost edge, see the patience I am having. Here is total 410 minus 212.518 is 197.482. 197.482, or see, with Eterco we got same Y bar from that side, 197.482. If you go for Eterco, then this is your X bar. See, X bar this way, Y bar this way. These are all told thousands of times This is centroid G for the complete lamina. Now our question number 163B is to find what? Is to get moment of inertia about centroidal axis, that is about xx and yy. For that, first you have to locate xx and yy. We are located as neat as possible. Then remember, when you go to the third part, that is 163C, at that time we need the complete area. I will not tell once again. The complete area is 115162.775. I noted down there because I can't go back to recording and check it. Because if I go to recording, the setting is gone. That adjustment of screen. Therefore, I noted down 115162. See this number. I will tell at that time. During x bar y bar calculation, we also got total area 115162.775. This full I will remove now. Everything is over. Now we go for the last part of calculation of I about xx and I about yy. I will do one thing now. Since class is going to be very lengthy one, I will write the expression and then explain. Of course, see, IG, I will do one thing now. First, before starting, see. Now, calculate, instead of wasting time, calculation of moment of inertia about centroidal axis, that is Ixx and Iyy passing through centroid G. We have by parallel axis theorem, right, I about, to save the time, I about any axis equal to, pen cover gone, here, okay, equal to, see, green color, but writing is black, Ig plus area into the most powerful term, h square. What is the meaning of this term? If somebody will ask now, I will tell, don't continue my class. Okay, this already. Now I will go for calculation one by one. See, first I will go for Ixx. See, here. I hope space is okay. Calculation of Ixx. I want the answer this time. Ixx. So you require, as usual, Ixx 10 times. I will write and then I will explain. But even if I write here, see, Ig and area I should not explain. It is explained thousands of times. So the last term, distance square, I will explain here. You should not see here. You should listen what I am telling, write it, then check it. So I will make ready for the resumed. Now, little space problem is there. I am adjusting it now. See, I will give the answer little later. I about xx for all 9-10 parts. Everywhere Ig plus area. This already over when I do, see, when earlier in the 163A, we did I about what? PQ. At that time also, first step is what? Ig plus area into distance square. The distance will change now. So everywhere, this I should not explain. See, start. I about xx. First one, where here? Own axis. Again, I am telling, I am not explaining. Still, I can't prevent myself from telling briefly. 110 into 50 cube by 36 plus area into this distance square. See, xx. 197.482 minus 150 minus 2/3 of 50 whole square. Calculate the answer. First answer will come 0.9325 into 10 to the power 6 millimeter power 4 is the first answer. Remaining answer, there is no place to write. I will tell what to do. Okay. Second one, I about its own axis. 110 into 120 cube by 36 plus area into, see, this distance square from G2 to XX. This side, 212.518 minus 90, don't see 65. If you see 65, 25 and 65. 90 minus 2/3 of 120 whole square. Okay, get the answer. Third one, I about its own axis. 200 into 150 cube by 36 plus area into this distance square is 197.482 minus from here to here is 2/3 of 150 whole square. I first wrote 120 there, so I changed it to 150 by mistake. Fourth one, I about its own axis. Pi d power 4 by 64 plus area into this distance square. 197.482 minus 50 minus half of 45 whole square. Fifth one, I about its own axis. 0.00343 into diameter power 4 plus area into this distance square is 197.482. Be careful, we want this distance square from G5 to XX. So 197.482 subtract 150, you will get this distance plus 2d by 3 pi whole square. Sixth one, I about its own axis. 100 into 150 cube by 48. Why 48? I am not telling now. Plus area into the G6 to here. This distance square is 197.482 minus 75, midpoint. Seventh one, I about its own axis. 350 into 170 cube by 12 plus area into this distance square. 212.518 minus 90 minus half of 170. Eighth one, I about own axis. Pi by 128 into diameter power 4 plus area into this distance square is 212.518 minus 90 minus this distance is half of 120 or diameter by 2 whole square. Ninth one, I about its own axis. 150 into 90 cube by 36 plus area into this distance square is 212.518 minus 2 by 3 of 90 whole square. Last one, I about its own axis. 0.00686. This reason I am not telling. There I told pi by 128. Here 0.00686. If this is not clear, you are not studying from me. 0.00686 diameter power 4 plus area into this distance square is 212.518 minus 90 will give you this distance. See, 212.518 minus from extreme edge minus that 90 plus 2d by 3 pi whole square will give you last answer. Now, see, the answers are, there is no place here. See, first answer I told 0.9325 10 to the power 6. 1 minute now. I will turn the camera slightly now so that you can see the answers. Slightly, I will turn the camera. See now. Note down the answer afterwards. Okay, see now. Okay, now. Second answer is here. Everywhere 10 to the power 6 I have not written. See, no, make it note. Every answer is what? Whatever number I wrote. 17.2114 10 to the power 6. Next answer. 161.2911. 25 point, this number. 0446 10 to the power 6. 246.0782. 119.5451. 227.0481. 27.1914, 160.0542, 151.4920. Now, the last step. This is something else actually, don't worry. Therefore, right, moment of inertia of the entire area, including the considering the cutouts, 2 cutouts are there, about horizontal centroidal axis, that is I about xx is, you should show the calculation, 1 minus by 1 plus 2 plus 3 minus fourth one. Here, see, 1 plus 2 plus 3, danger, minus 4 plus 5 plus 6 plus 7 minus 8 plus 9 plus 10 will come 1031.4166 10 to the power 6. I will make a note here. 1031.4166. I require it now. 1031.4166 10 to the power 6 millimeter power 4 is the final answer. Now we will go for I about yy. Again I will write and explain same way. Answer the corner I will write for space problem. Resume. Okay, now I about yy. See, little fast I will do now. Too lengthy class. First, I about its own axis. You write it. Plus area into, see, now IG you should write. I won't explain time. It is written there. See, 50 into 110 cube by 36 is written there. By this time, if you cannot write IG, then why you are coming to my class? So, IG plus area into this distance square. One small correction. Earlier, when I marked YY axis by mistake, see, I did not see this side. I took, this is 2, see, I took 278 from here and 281 here. Actually, see, the 278.435 is from the extreme left, but luckily no effect because it is not used so far. See, I by mistake marked from here. It is actually from here. See, it is actually marking mistake. I did not see that side. 278.435 is from here, whereas that subtracting 281 is from here. See, from here it is 281.565. Small correction. By mistake I thought this is the total length. 2 extra offset I forgot. Anyway, see, when I wrote moment of inertia, I can make out. When I looked there, answer was not tallying. That is, distance is coming negative. So I realized the mistake. Marking mistake. So last time, see, X bar is from here, other is from there. Y bar remains same. Okay. He's also playing with me. Okay, start now. See, I about its own axis. Okay, I will tell. How much this axis? 50 into 110 cube by 36 plus area into this distance square is 278.435 minus 2/3 of 110 whole square. Okay. Answer I will tell you later. It is written there. Second one, I about its own centroidal axis. Here, see, this is actually two separate rectangles, triangles here. Be careful. These are two separate figures here. So it is how much? 120 into 110 cube by 36 plus area into this distance square. See, this distance square. I can use it now because I don't want it now. 278, red color, okay. This distance square. 278.435 minus 2/3 of 110 whole square. Now I can use red color. 3. See, first I about its own axis. Here, its own axis. 150 into 200 cube by 36 plus area into, see, this distance square is 278.435 minus 110 minus 1/3 of 200 whole square. Now I can use because I am rubbing out. Fourth one, see, I about its own axis. You can use pencil for this one. 5d power 4 by 64 plus area into, see, this distance square is 278.435. See, if you use a pencil that way, it is very useful. Once you mark with a pencil, see, 278.435 minus 110 minus 15 minus half of 45 whole square. I about its own centroidal axis. 0.00343 diameter power 4 plus area into, see, this distance square. That is 281.565 minus 100 minus 2 into diameter by 3 pi whole square. Sixth one, I about its own centroidal axis here. That is how much? It is 150 into 100 cube, 150 into 100 cube by 36 plus area into G6 to here. It is actually which one? See, it is this distance square. That is how much? 281.565 minus 2 by 3 of 100 whole square. Seventh one, I about its own centroidal axis. 170 into 350 cube by 12 plus area into, see, small this distance square is, see, just this distance square. 281.565 minus 100 minus half of 350 whole square. I about its own centroidal axis. 0.00686 into diameter power 4 plus area into, see, this distance square is 281.565 minus 100 minus 2d by 3 pi whole square. I about its own centroidal axis. Parallel side, 90 into 150 cube divided by 48. I will not explain why 48. By this time, if this is not clear, I cannot tell anything. Plus area into, see, this distance square is 281.565 minus 100 minus 75 whole square. Lastly, I about its own centroidal axis here. That is pi by 128 into 130 power 4 plus area into this distance square is 278.435 minus 110 minus half of 130 whole square. This is the answer. Now, right here. Lastly, this is not there. Right here. Therefore, moment of inertia of the entire lamina or entire area is considering the cutouts about the vertical centroidal axis. That is IYY equal to 1 plus 2 plus 3 minus 4 plus 5 plus 6 plus 7 minus 8 plus 9 plus 10 1816.5284 10 to the power 6. If you want each part answer, I will show you now. See, I slightly turn the camera. I will dictate from here only. I won't go there. I won't go to the board. See, for first one answer, 117.5320 10 to the power 6. Second answer, 282.0768 10 to the power 6. I won't tell 10 to the power 6 now. Third one, 188.6852. Fourth one, 27.4676. Fifth one, 273.4361. Sixth one, 350.5264. Seventh, 609.9602. Eighth, to be subtracted, 139.2162. Ninth, 82.9818. Tenth, 78.0137. You get that answer. Okay, I'll turn the camera now. Okay, I'll let it be there. Now, question number 163C. Okay, see now someone will tell, sir, this is the same sketch, sir, which you removed just now. Yes, I removed it. But I did not, but you did not write once again, sir. See, what all I can see earlier, you can see now also. See, this stain here, this mark here, this gap here. It is like a signature. It is not removed. That is my trick only. Okay, see now, 163C. Once again take as independent question. Imagine question is given just now class started. What question is? See, I'll tell once you see. The question is, find moment of inertia about centroidal axis. See, centroidal axis they want. That is XX and YY. And hence find moment of inertia about PQ and RS. Once, don't tell, see, last time answer. Don't see previous part. Independent question. See, a sketch is given where they randomly marked two axes. See, one of them is PQ, other is RS. Okay, how? Randomly. It is same as earlier. Okay, but independent question. So, question is, Here, see, write a note here. Here also, right here also. First, remember, first we have to see, two parts are there. There are two parts here. Part 1 of the question. Part 1 is to find moment of inertia about centroidal axis. Centroidal axis, that is I about xx and I about yy. Where xx and yy, you write here, xx and yy are horizontal and vertical centroidal axis passing through, right here, passing through centroid G for the entire area. For the entire given area, complete area, centroid G. Don't see PQRS. In the first part, PQRS is not there. No. Therefore, what to do is first divide into parts. Yes, already over earlier. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 warning parts are there. 4th and 8th. Okay. Get all the dimensions. All clear. Then, first to locate centroid G. You write here. You should write everything. If you are really serious, write everything. First to locate centroid G. Then mark centroid here. Then once you mark centroid here, you can go to either Abelco or Eterco. Your choice. Both will go. Once you mark the centroid there, then using parallax theorem, see, I don't know where it will come. Find Ixx and Iyy right here. Mark centroid G, then mark xx and yy, and find Ixx and Iyy. Get the answer. Make a note. Oh, it is just now over. Right here. It is just now over. Just now over in question number 163B. See, just now I removed it. In 163B, question was find moment of inertia about centroidal axis. So that full repeat. You don't have, if you want, write once again, but nobody will write, I know it. So you can refer 163B. But make a note, 163B was only to find see, this note is very important. 163B, just now earlier over, is only to find Ixx, Iyy. But here, after finding, see, first they want, after finding Ixx, Iyy, they also want to find I about PQ and RS. Now second part, see, now second part is, for this one, second part is to find I about PQ and I about RS. Remember, hence find means what? Common sense. You go there and you investigate and hence write the report. Means whatever you investigated, you write here. Study and hence pass in exam. Get good marks. Study thoroughly and understand the subject. Means study thoroughly, hence you understand. Means now to find I about P, you should write all these. To find I about PQ and I about RS, you have to use that I about XX, YY. That directly you can do. So IPQ, IRS, you need not go for part by part. You consider the entire area as one unit with properties, all the entire area as one unit with already calculated total area, I about XX, I about YY, and then transfer it to PQ and transfer the moment of inertia to PQ and RS. I will explain once again, don't worry. See, or I will tell lastly now. 163A is independent question to find IPQ and IRS. No centroid, nothing, over. 163B is only to find Ixx, Iyy. Of course, you have to locate centroid. But 163C, what you are doing now is to find what? To find first Ixx, Iyy means moment of inertia about centroidal axis, and then hence means what? Hence find means using that, see, using this result, you can write here, that is using what? Already calculated Ixx and Iyy, calculated Ixx and Iyy, find IPQ IRS. Okay, that I will explain now correctly, but remember now, so for this one, you require centroid location for entire area, already over, and what is Ixx, Iyy, you require already over. Therefore, now I will continue and systematically explain to you how to do it. Now I am going to remove the entire board. See, entire board I am removing now. Okay, now see here. This I will rub now. This time I am really rubbing. Why? Further not required. This time I am really rubbing. In front of you I will rub it now. See here. In front of you only I will rub it. Because now no trick. Sometimes people wonder, already rubbed earlier, but once it vanished, again it came. That is arrangement of the recording. Because luckily for me, no confusion. Actually, that X bar, Y bar, still I have to do it. That I have to still do it. IPQ, IRS also still have to do it. But I will do it and put it there where requirement is there. Okay, this is over now. This I am not rubbing. This also I am rubbing now. See, rubbing, fully rubbed out. Okay, now I will continue. Now we are in the last part of this marathon question, but fully concept-based question. See, I told you, if you want to understand everything, go through and write all explanation given by me. This is already told earlier. Last time I am telling. Question, see, 163A was to find I about PQ and I about RS. Randomly given. Okay. Then what you have done? You divide it into 10 parts. Then by parallax theorem, for each part, we found moment of inertia first about PQ, Ig plus A square, etc. Then again repeated 10 more times for I about RS. And our answer is here. See, IPQ we got 1032.1464. I will note down. And I about RS we got 1931.2696. 10 to the power 6 we already got. Question 163A is over. Question 163B is same question given. They want moment of inertia about centroidal axis. So this is just now we finished it little earlier. Therefore, you treat each of them as independent question. See which one? 163A independent, 163B also independent. Don't see 161A. Then first locate centroid. We got X bar and Y bar. We considered both Abelco and Terco for confirmation. Finally, part by part, moment of inertia we got. That answer is C. For the entire lamina, centroid is here. At that time, I put capital G. Now I am putting small g. I will tell the reason. And centroidal horizontal axis, see, at that time I called capital XX, red color. This time green color, I will call XX. That time YY, I took red color YY, passing to capital G, this time green color. X bar we got 278.435, from that side 281.565, total 560, 410, this is the X bar Y bar we got. Then we found there I about capital XX, I about capital YY. I about capital XX, that time it is capital XX. Now I am telling small xx. we got 1031.4166. No. Oh, what is this one? Not 10, yes, 1031.4166, 10 to the power 6. And I about YY, we got 1816.5284, 10 to the power 6 millimeter power 4. Just now, this is question 163B, result of question 163B as an independent question for finding moment of inertia about centroidal axis. Now we are in the last part, question 163C, where question is, it is not independent. See, there are two parts in the question. First part is find moment of inertia about centroidal axis. That is IXX, IYY. Therefore, in that question, first you locate centroid and find IX, IYY. So that is exactly same as 163B. Remember, it is same as 163B. Write the answer. And in the same question now, 163C, second part is there. Using that IXX, IYY calculated, find I about PQ and I about RS. Now, you can find I, you already found long back IPQ, IRS by dividing into 10 parts. No. Since for the entire lamina, you know the entire lamina or area as one compact, no division, nothing, as one compact unit. Entire area is one compact unit. You know centroid, you know centroidal axis. See this way. And also, you know the area of the entire lamina, small a I will take, y part. And you know IXX, IYY. These two are nothing but, I told already, we got the answer. Now, to second part is, I told I about centroidal axis, and hence find means what? Use it. So you need not waste time like 163A, where 10 parts are there for PQRS. No. What you do is, see, you write here, I will take a statement here. Consider, I should not write actually, okay, write here now. Consider entire area as one unit, one single unit. For that, write properties. See, all these are known. See, now YYXX known. Your PQ is here. See, if you remember PQ, how much from bottom edge here? See, it comes below XX. So, see, 90 plus 120. 210 is the distance from bottom edge to PQ. Okay. Now, same way, RS here is from this side. If you take 100 plus 150, this is 250. It is given in the question. Okay. Now what you do is, you use this IXX, IYY. I will remove this one now and find IRS, IPQ, IRS. Now do one thing. For the entire unit, by parallax theorem, you write here. Parallax theorem, see. But I write here now. To save the space. See. Red color. See. By parallel axis theorem, I about any axis equal to what? Ig plus area into h square. Okay, start. Therefore, I about your PQ equal to, see correctly, I'll check the camera once. Oh, no problem. Okay. Recording is on, no? Yes, correct. I about PQ you want. See now, correctly. When you want I about PQ, first come to centroid. Complete area as one unit. Its centroid is here. I about an axis, see this one, not this one, centroid is here, see, G. I about an axis passing to centroid parallel to PQ is this XX axis. I about that axis. How much answer? So, 1031.4166 10 to the power 6 is Ig plus full area is The full area. I see here 115162.775 multiplied by from centroid of the component or this entire area to the required axis, this distance square, that is, see, this is 212.518, that was your y bar earlier. From 212.518 subtract 210. I wrote here, see how I got this distance. From 212.518 subtract 2.518 square. 518 square. Calculate the answer. Same way, I about RS. RS equal to, first, this all I explained earlier. I about an axis passing to centroid parallel to RS. Here, this axis. That is your YY earlier. 1816.5284 10 to the power 6 plus area 115162.775 into, see, from centroid G1 to RS perpendicular square. This is 281.565. This is 250. That's how you got 31.565 whole square. Calculate the answer. Oh, our class is only 3 minutes more now. I will really calculate. No cheating this time. No cheating. 1031.4166. And I got confidence 10 to the power 6 plus 115162.775 into 2.518 whole square. How much? Divided by 10 to the power 6. 1032 answer. 1032.1468. 1468 10 to the power 6 millimeter power 4. Our earlier answer was 1032.1464, 1032.1468. That is 0.0002 in or this much lakhs, this much 100 in 10 lakh 30,000 rupees transaction, 2 rupees difference. Yes, okay. Oh, yes. Right here. Thumbs up. You tell, yes. That difference came because of rounding off error. See, actually, it is not 278.435. It is 278.4351802. That's all we rounded off because of that one. See, how much I told? See, here difference came. That is around 10 lakh. Around nearly 10 and a half rupees transaction, some 2 rupees shortage. Who will bother first of all? Same way, IYY will come, IPRS will come, 1816.5284 10 to the power 6 plus 1151, then 62.775 into 31.565 square. No cheating. Divided by 10 to the power 6. 1931, I am not seeing there, 0.2707, 2707, okay, 270, see, 2696, 2696 is 270 only, 10 to the power 6, millimeter power 4, again incorrect, see, that is 0.270, 27, how much? 2769 is 270 only. Point not now. Again, same. 1 rupee, 2 rupee, 3 rupee, 4 rupee, 5 rupee difference in lakhs of rupees. It does not matter. Tell me. Perfectly. Yes. Now write a note here. So if you know the concept, if you got the basic concept, and also thorough understanding if you get, and sincerely if you work out, what miracle you can do in structural engineering, learn from this example. See how much patience I have shown to calculate each and everything. See, I had confidence. I know answer will come in my class When I tell answer will come, it will come. No question can escape from me without giving answer. Sometime it happens. In a class, someone will tell, sir, if I do from this side, sir, bending unit is coming 71.5. That side, sir, it is coming how much? 71.498 is okay. Sir, it is coming 77. Go home. I will tell no. Nothing doing. Not in my class. That you get elsewhere. In my class, if it is 71.8 here, 71.8000 something or 7999 something because of rounding off error. It cannot come, see, some very minute difference can come. That is because of rounding off. Okay, with this one, I am winding up this part 3, that is centroid and moment of inertia. Next, I am going for friction, last part of engineering mechanics. And in case I feel any extra questions are required, suppose due to any reason, later, I will prepare a separate playlist where I will put engineering mechanics, extra questions for part 3 I will write. You add it to the notes. And always, you maintain separate notes. So this note, leave it now. When you go to friction, have separate book. If any addition comes, add to this note. Okay. At least now onwards, be serious and start gaining more and more knowledge. Okay, thank you. Next class we'll meet with the friction.